We're starting with fluid mechanics, last lecture. The diagram given in the question. This is the valve. Now, please write the question. When the valve is opened, the liquid is redistributed till the level becomes same. Till the level becomes same. In this redistribution, there is always a loss of gravitational potential energy. Find the common height after the liquid is being redistributed and second part is the loss in potential energy, loss in gravitational potential energy in redistribution. Okay, so what are they telling you? Okay, this is the liquid which is there. It is rising up to a height of 2h in a container of area of cross section A, and over here the height is h, the area of cross section over here is 2a. When I open the valve, okay, liquid will get redistributed such that the height will become the same. I want to find the common height. Means at this level, this will rise and this will fall, and I want to find this common height. Getting it? So, if I draw this diagram again with the common height, it will be somewhat this way. The side is going to rise. So suppose both of them have common height over here. This cross section area is A. This cross section area is 2A. This height is common height, h common. I need to find this. And in this process, they are telling you that there is a loss in gravitational potential energy. How much is the loss in gravitational potential energy? Okay. We know that what remains constant over here. When the liquid is getting redistributed, what remains same? Volume is the same. Because if 10 liters of water is there over here, 10 liter will come here also. So initial volume and the final volume will remain the same. Vi will become Vf. This is the first answer which I am solving. What is the initial volume in this container? This part, how much is the water volume? A into 2H. This part I am not considering because the redistribution doesn't take place over here. Okay, if you want to take this as V, you can take this as V, but both of the sides will cancel. Over here, the volume is 2A into H. So initial volume of that side will become A into 2H plus 2A into H is the initial volume of this container. How much is the final volume of this part? A into H common. This part I am not considering. It will become 2A into H common. So total, how many A's are there? 3A into H common. So it will be 3A into H common. So A will cancel throughout. H common is going to become 4H by 3. Is correct. This is the first answer. By which this H common will come as 4H by 3. So they are achieving a height of 4H by 3 after getting redistributed. ठीक है? Now we need to find second part. How much is the change in the potential energy? There is loss in the gravitational potential energy. Means initial is more, final is less, and the change will be potential energy initial minus potential energy final. What is the formula for potential energy? mgh. m को लिख सकते हैं, m तो पता नहीं है हमका. m को लिख सकते हैं density into volume of this part. This part I am not considering. This part, so that will be initial potential energy. We'll see over here. This is the first part. How am I doing the second part? Initial potential energy will be mgh of this part. Please tell me mgh of this part. m क्या रहेगा इसका? Density into volume बताइए उसका. 2a 2h into a. ये हो गया m. g. Correct? Now pay attention. Where will h come? This whole thing, okay, is a continuous body, and that mgh is valid only for point masses. So you have to concentrate this whole mass where? At the center. H, that will become h by 2. So it is 2h by 2. I am writing it for the sake of understanding. You can write h also. So it is h by 2 of that thing. अच्छा, इसका बोलिए अभी ये क्या हो जाएगा? ये इस पार्ट का रो. ओके, ये हो जाएगा h इंटू 2a. ये तो सेम ही है. g h by 2. Are you all understanding what's happening? ये आप कैलकुलेट करेंगे. Whatever answer you will get. Clear है? Okay, you will get in terms of rho h a h. So h square के terms में whatever you get some answer. Clear हो गया? Now you will tell me U final कैसे निकालेंगे? U final इसका है ना? Okay. Now can I add both of them? Can I say both of them are h common? So ये एरिया हो जाएगा टोटल 3a. mgh है ना बेटा इसका. m क्या रहेगा? Density into volume. So density is density. Volume is total area. What is the total area? 3a into h common, that I'll write hc. ये हो गया हमारा m. g h क्या लिखेंगे? h common by 2. So this can also be written as rho 3a g h common square by 2. ये आप वैल्यू निकालेंगे. Come on, can anyone tell me what will be delta potential energy? Delta potential energy will become U initial minus U final. ये आंसर आप निकालो, आंसर आपको आ जाएगा. ओके, everyone should calculate. We are discussing about time taken to empty the tank. There is a tank which is filled up with a liquid of height h. Tank का area of cross section is how much? A, capital A. There is a hole at the bottom of cross sectional area small a. Okay, I want to empty the tank. The time taken to empty the tank is capital A upon small a under root 2h by g. I'll prove it after some time. ये आपको याद रखना है. Capital A depends on capital A first. Okay, so greater is this area, more will be the time. Understand? And it also is inversely proportional to small a under root 2h by g, where h is the height. On the basis of this, we'll do one question which is very famous, then I'll prove it. ठीक है? Write a question. First question. Time taken to empty first half. To empty first half. That is from h to h by 2. h to h by 2 is t1. And the second half, that is h by 2 to 0, is t2. Find a ratio of t1 to t2. ठीक है? 1 minute, try. फॉर्मूला आपके सामने है. फॉर्मूला आपके सामने है. ओके, h to h by 2, h by 2 to 0. Ratio of that thing. Capital A and small a is the same. ठीक है? Look over here, please. We want T1 is to T2. That is the time from h to h by 2 and then h by 2 to 0. Can I write this as, this is h to h by 2 and this is h by 2 to 0. Can I write this as time from h to 0 minus time from h by 2 to 0? देखो ना, अपॉन टाइम h by 2 to 0. देखो, बोलो, करेक्ट है? Can I write this as time from h to 0, h by 2 to 0 minus 1? क्लियर है? ये कितना भरा हुआ है फुल? h. At this instant how much is filled? h by 2. Can I put the respective root h over here? Because over here how much will come beta? Root h will come because it is proportional to root h. And over here it will come what? Root of h by 2. देखो, क्लियर है? बिकॉज दोनों को 0 पर जाना है. एंड दिस इज फ्रॉम h to 0. दिस टाइम इज फ्रॉम एम्प्टी द टैंक ना, तो फ्रॉम h to 0. तो ट्रिक ऐसे अपनाना है ताकि 0 पर लेके जाना है. दिस विल नॉट वर्क. So this will become -1. This answer will become √2 minus 1. That is 0.414. Is the answer. Next question. Question tells you in the form of comprehension, the inflow rate is alpha. The inflow rate in the tank is alpha, which is constant. Is meter cube per second. It's constant. The outflow rate is Q2. The outflow rate is Q2, which increases with H. Which increases with H. कैसे? Last time हमने ये प्रूफ किया था Q2 is AV, but velocity at this moment is under root 2gh. ये अभी प्रूफ किया हमने. तो Q2 is proportional to H. तो जैसे H बढ़ता जाएगा वैसे Q2 भी बढ़ता जाएगा. ठीक है, आगे लिखो. Initially Q1 is greater than Q2. Q1 is greater than Q2. As height will increase, Q2 will increase. At a certain height, Q1 will become equal to Q2. The inflow rate and the outflow rate will be the same. Find that height. Okay. Question समझ में है? Solve करो, 1 मिनट है. You know everything now. On the board it is there. सिर्फ equate करना है दो चीज़ों को. मतलब उन्होंने क्वेश्चन में सब कुछ दे दिया है. We just have to put it in the formula. Put the heading as viscosity. Viscosity. Viscosity is just like friction. First point. Viscosity is just like friction. What is the difference between viscosity and friction? सिर्फ ये देखना. Does solid friction depend on area? No, it's mu n ना. N is mg cos theta. पता है ना? Solid friction is independent of area, but liquid friction depends on area. Area of contact, huh? Liquid friction depends on area of contact. Okay, इधर. Suppose the body is there, is going with 1 meter per second. Which friction will come? So, static or kinetic? Kinetic friction will come. Suppose kinetic friction is Fk. यहाँ पर is some value. Suppose 10 Newton. Now this body attains 10 meter per second. How much is the kinetic friction? 10 only. 10 only. Kinetic friction doesn't change with relative motion over here. मतलब if you increase the relative motion or decrease the relative motion, static condition is different. Huh? But once the motion is there, whether you're going 1, 2, 3, 4 or 10, the kinetic friction is going to remain 10 only. But it doesn't happen in liquids this way. Are you all understanding? नेक्स्ट पॉइंट लिखो, द विस्कस फोर्स, इस फोर्स को लिक्विड में कहते हैं विस्कस फोर्स. द विस्कस फोर्स डिपेंड्स ऑन मैग्नीट्यूड ऑफ रिलेटिव मोशन. डिपेंड्स अपॉन magnitude of relative motion while solid friction does not. Solid friction does not. Viscous force depends on magnitude of relative motion between them. Clear है ना एकदम? Now next point, put the heading as velocity gradient. Velocity gradient वेलोसिटी ग्रेडियंट क्या है? ग्रेडियंट का मतलब क्या होता है? विद रिस्पेक्ट टू डिस्टेंस. सो सपोज दिस इज द सी बेड. यहां पर वेलोसिटी कितना होगा? 0. लिक्विड विल फ्लो इन लेयर्स. दिस इज द फर्स्ट लेयर, इट्स गोइंग विद v1. v2 will increase, v3, v4. V is 0, V1, V2, V3, V4. Can I say there is a change in velocity with respect to height? Vg, velocity gradient, is dV by dy or dV by dh. Yeah. This is the variation in the height, and you can see there is variation in the velocity also. Clear हो गया? अच्छा ना, 2 लेयर्स है, सुनिए. एक लिक्विड का लेयर ये है, एंड द सेकेंड लिक्विड लेयर इज दिस. दिस इज गोइंग विद v1, you know it, and this is going with v2 which is less than v1. upper layer always has more velocity. Okay, दरिया के ऊपर ही वेव्स होता है ना, अंदर जाके देखिए तो वेव्स नहीं होता है. मूवमेंट इज मैक्सिमम ऑन द टॉप मोस्ट लेयर. इसी के बीच में आई वॉन्ट टू मेक द फोर्स ऑफ फ्रिक्शन. इफ आई वॉन्ट टू मेक द फ्री बॉडी डायग्राम, आई विल ओपन दिस वन. कौन बड़ा है? P1 is bigger, so relative motion is here. Where will be the viscous force? This way. देखिए ना, ये आगे बढ़ रहा है with respect to him. The friction always tries to kill the relative motion. 2 पे कहाँ रहेगा? In the same direction, because it is an internal force, it has to cancel. It is acting like solid friction only. Are you all understanding? Just make this, then I'll do sums based on this. Velocity gradient is dv by dy. Now, there are 3 formulas in viscosity which are very important. On the basis of these 3 formulas, you can solve all the sums based on this. Look over here now. सबसे पहला formula, viscous force is eta A dV by dy. जो हमने विस्कस फोर्स अभी बनाया था बिटवीन द 2 लेयर्स, विस्कस फोर्स का फॉर्मूला क्या रहेगा? जैसा सॉलिड फ्रिक्शन का फॉर्मूला क्या था फोर्स का? म्यू एन. एन वाज डिफरेंट, कंडीशन वाज डिफरेंट. रिमेंबर, स्लोप पर ऐसे. वैसे एफ वी, विस्कस फोर्स इज ईटा. ईटा इज कॉल्ड, व्हाट इज म्यू कॉल्ड एज ओवर देयर? कोएफिशिएंट ऑफ फ्रिक्शन. एंड वो 2 टाइप का था, कोएफिशिएंट ऑफ स्टैटिक फ्रिक्शन एंड काइनेटिक फ्रिक्शन. ये इसको बोलते हैं कोएफिशिएंट ऑफ विस्कोसिटी, डिपेंड्स ऑन एरिया ऑफ कॉन्टैक्ट। dv by dy अभी पढ़ा क्या है, velocity gradient. So Fv between the two layers of the liquid will become eta A dv by dy. Many times the question has come in NEET, prove the dimensions of eta. आप लोग ट्राई करो, eta का डायमेंशन निकालना है। Dimensions of eta, come on fast please. पहले उसका यूनिट निकालो और यूनिट से उसका you remove the dimensions. We call this as 1 decapoise. This is which unit? SI unit. CGS unit of this is poise. लिखिए, CGS unit of this is poise. 1 SI is 10 CGS. 1 decapoise is 10 poise. Because sometimes calculation will come in terms of CGS, sometimes it will come in SI. Are you understanding? ये पहला चीज है, क्लियर हो गया? नेक्स्ट, पुट द हेडिंग एज टर्मिनल वेलोसिटी. टर्मिनल वेलोसिटी पीटी, ध्यान देना अभी, या पहला फॉर्मूला हो चुका, ईटा ए डीवी बाय डी वाई, ईटा ए डीवी बाय डी वाई. इसके ऊपर सम्स वील डू इट लेटर. ओके, 4 to 5 sums we will do together on the basis of these 3 equations. Terminal velocity, what happens? Suppose there is a sphere of radius r, of density rho 1. It falls down in a fluid of density rho 2 and coefficient of viscosity eta. A raindrop falling down. Okay. A lead shot falling in water. Bubble rising up in water, in a liquid. Getting it? तो जो स्फीयर होगा उसका रेडियस कितना लेंगे यार, उसका डेंसिटी कितना लिया मैंने यहां पर, रो 1, जिसके अंदर इट इज हैपनिंग, इट इज रो 2 एंड इसका कोएफिशिएंट ऑफ विस्कोसिटी था मचीटा. वी टेक अ बेसिक एग्जांपल ऑफ अ रेन ड्रॉप फॉलिंग डाउन. ठीक है, रेन ड्रॉप फॉलिंग इन एयर, तो ये हो जाएगा डेंसिटी ऑफ लिक्विड वाटर एंड ये हो जाएगा डेंसिटी ऑफ एयर. क्लियर है ना? नाउ लिसन टू मी, व्हाट विल एक्ट डाउन, वेट. ये वेट के कारण नीचे गिर रहा है. वेट कितना है mg, मास डेंसिटी इंटू वॉल्यूम. वॉल्यूम को लिख सकते हैं बेटा 4/3 पाई r क्यूब जी, एंड रो इज रो 1. रो 1 है ना, बोलो करेक्ट है? तो ये रेन ड्रॉप नीचे गिर रहा है, ऊपर क्या एक्ट करेगा, अब थ्रस्ट तो होगा ही. यस, अब थ्रस्ट इज you know it is V rho g. V rho g. V कितना है, 4/3 पाई r क्यूब. रो इज रो 2 इंटू जी. करेक्ट है? बट दिस इज कांस्टेंट. इज दिस कांस्टेंट और चेंजिंग? 4/3 पाई r क्यूब कांस्टेंट है, रो डेंसिटी ऑफ एयर कांस्टेंट है, जी कांस्टेंट है. So W is also constant and U is also constant. And who is more? Obviously W will be more. That means it is going to accelerate down. Because where is the net force acting? Down. ऐसे होगा, 1 मिनट. रेन ड्रॉप जब गिरता है किलोमीटर्स ऊपर से तो उसका वेट ज्यादा होगा, अपथ्रस्ट कम होगा, नेट फोर्स कहां बनेगा? नीचे। तो नेट एक्सेलरेशन कहां बनेगा? नीचे. दैट मींस it will change its velocity and increase and increase and increase and hit us like a bullet, accelerating. Okay, but when we go out on the rain we feel very pleasant. It is coming down with constant velocity. ये क्या इंडिकेट कर रहा है? कि इट हैज एक्सेलरेशन. बट हमको पता लगता है कि एक्सेलरेशन तो है नहीं उसके पास. It is falling down with constant velocity. That velocity is called as terminal velocity. Now वो क्यों होता है, वो कैसे होता है, that we are discussing. क्वेश्चन समझा आपको? ये ऐसे कंडीशन नहीं होगा. ऐसे कंडीशन होगा तो it will hit you like bullets. कांस्टेंट वेलोसिटी से जाना है, नेट फोर्स को जीरो कर देना है. मतलब द डाउन फोर्स एंड द अप फोर्स शुड बिकम जीरो. लुक ओवर हियर नाउ. ओवर हियर देयर इज अ फोर्स एक्टिंग बाय नेचर. इज गिवन बाय स्टोक्स लॉ. इट इज गिवन बाय स्टोक्स लॉ. The force acting on him, the viscous force acting on him will become 6 pi eta RV. यही फॉर्मूला याद रखना. तो दूसरा वाला, पहला वाला विस्कस फोर्स क्या था? बिटवीन द टू लेयर्स, eta A dV by dy. By Stokes law, the second formula of a solid moving in a fluid or for another liquid moving in another liquid, or sorry, moving it in gas or something. This will be the formula 6 pi eta RV. R क्या है इसका? रेडियस. V इसका वेलोसिटी. अभी ध्यान दीजिए इधर कैसे होता है नेट फोर्स जीरो. Suppose at the instant when it starts falling, कौन बड़ा है? This is more, this is more. Weight is more. Weight is more मतलब net force is more. मतलब it will start accelerating in the downward direction. Accelerating का मतलब होता है स्पीड का बढ़ना. If the speed will increase, can I say this component will increase? If this component increases, Fv increases. Okay, and it is trying to balance the weight. That means this plus this is trying to balance. Can I say वो गिरते 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 एक स्पीड ऐसे आएगा where the total upward force and the total downward force will balance. That velocity is termed as which velocity, beta? Terminal velocity. At terminal velocity, downward force and upward force will be the same. So can I say at Vt, we are deriving an expression for Vt. Rho 1 4 by 3 pi r cube g is equal to 4 by 3 pi r cube g into rho 2 plus 6 pi eta r Vt. भाई यही तो हुआ ना. डाउनवर्ड फोर्स एंड अपवर्ड फोर्स सेम हो गया. नेट वेलोसिटी ना कांस्टेंट वेलोसिटी पर. आई विल अंडरस्टैंडिंग. यहां से Vt का इक्वेशन आपको मिलेगा. ओके, राइट दिस डाउन. You will get. आपको याद यही रखना है. ओके ये क्लियर है? कितने 3 फॉर्मूलास? पहला फॉर्मूला eta a dv by dy. Second formula is Stokes law, 6 pi eta r v. At vt only it is vt, 6 pi eta r vt, but generally it is 6 pi eta r v. And third formula is vt is 2 by 9 r square by rho, r square by eta, sorry. Coefficient of viscosity ना, g rho 1 minus rho 2. Correction है, eta आएगा यहाँ पर. Coefficient of viscosity rho 1 minus rho 2. Clear हो गया? Question number 1, write fast. A plate of area 2 meter square. A plate of area 2 meter square is made to move horizontally. Is made to move horizontally with a speed of 2 meter per second. By applying a horizontal tangential force. By applying a horizontal tangential force. Over the free surface of the liquid. Over the free surface of the liquid. Depth of the liquid is 1 meter. Depth of the liquid is 1 meter. The bed is stationary. The lowest level पे speed is 0, इसका मतलब. Coefficient of viscosity. Coefficient of viscosity eta is 10 raised to minus 3 SI. SI मतलब डेकापॉइज. ओके, अगर पॉइज देगा तो 10 raised to minus 1 करना पड़ेगा. याद रखना ये चीज. 10 raised to minus 1, you going back. minus 1 is 10 डेकापॉइज ना. ठीक है. ओके, फाइंड द tangential force. Find the tangential force. Okay. Find the tangential force applied. ठीक है, 1 मिनट में सॉल्व करो. पहला वाला फॉर्मूला यूज करना. थिंक एंड से ना. ये तो स्पेयर है. स्पेयर है क्या वो? Did you understand the question? भाई ये लिक्विड का फ्री सरफेस है. इसी के ऊपर हमको एक प्लेट ऐसे चलाना है with constant velocity. Where is the viscous force going to act? Backwards. What is the value of the viscous force? Eta a dv by dy. And I want to move with constant velocity. मतलब the net force on the system should become 0. Means जितना force पीछे लगाएगा उतना force आगे लगाना पड़ेगा. And what is the force which is acting backward? Eta a dv by dy. Calculate. You get the answer. चलो, this one. So Fe is going to act backwards now. And if I want to move with constant velocity, the net force should become 0. आप जितना लगाएंगे उतना ही यहाँ से आएगा. And what is the value of Fe? Eta A dV by dy. You get the answer directly. Answer -3 Newton. 4 and 2, 10 raised to -3. This is the answer. ठीक है बेटा. कौन सा फॉर्मूला? Eta A dV by dy. ध्यान रखना. This is the concept. Next question. Write fast. Two spherical raindrops of equal size falling vertically with a terminal velocity of 1 meter per second. Two spherical raindrops are equal size are falling vertically with a terminal velocity of 1 meter per second. बराबर है? What will be the terminal velocity? If these two drops combine to form a large single drop, सोचिए 1 minute में you should get the answer. Listen over here. See, whenever combination takes place, we have done the sum and surface tension. That capital R is n raised to 1 by 3 times smaller. This is the radius of the single drop, radius of the droplets. N is 2. 2 droplets are there. 2 raised to 1 by 3 times smaller. This is the relation between capital R smaller. ठीक है. अच्छा, पहले वाले का टर्मिनल वेलोसिटी इज 1, सेकेंड वाले का टर्मिनल वेलोसिटी व्हाट? इफ यू गो टू टर्मिनल वेलोसिटी का इक्वेशन, वी नो दैट इट इज प्रोपोर्शनल टू आर स्क्वायर. टर्मिनल वेलोसिटी इज प्रोपोर्शनल टू आर स्क्वायर. देखो ना फॉर्मूला भाई, 2/9 आर स्क्वायर बाय ईटा जी रो 1 माइनस रो 2. आर का फैक्टर कितना टाइम हो गया? 2 raised to 1/3. आई एम नॉट डूइंग 1/2. आप देखेंगे आर का फैक्टर इज बिकम 2 raised to 1/3. सो आर स्क्वायर विल बिकम व्हाट? 2 raised to 2/3. सो कैन आई से टर्मिनल वेलोसिटी 2 is going to become 2 raised to 2/3 times terminal velocity 1. What is the initial terminal velocity? 1. Getting it? Getting it now? Next question. With what terminal velocity? With what terminal velocity will an air bubble will an air bubble 0.8 mm in diameter, 0.8 mm in diameter, rise in a liquid of viscosity 0.15 SI with what terminal velocity will an air bubble 0.8 mm in diameter rise in a liquid of viscosity 0.15 SI and specific gravity is 0.9. Specific gravity is 0.9. Density of air is 1.293. ठीक है, ध्यान दीजिए इधर. VT. What is the formula for VT? 2/9 R square by eta ρ1 minus ρ2 into G. ये है, ध्यान दीजिए. 2/9. We only need the values, okay? Listen. R square. What is R? 0.4 mm. क्लियर है? रुक जाइए. ईटा का वैल्यू कितना दिया है? 0.15 ऐसा है. ये है. CGS में दिया रहेगा तो -1 करना पड़ेगा. 10⁻⁻1 याद रखना. G का वैल्यू विल टेक 10. What will be ρ1 and ρ2? This is important. Who is falling or rising in who? Look. Air bubble. So it is ρ1. And the liquid is ρ2. बराबर है density of air. So air bubble of liquid, density of air and specific gravity. So who is ρ1 over here? Density of air is ρ1 because this is air bubble ना. ये कितना है? 1.293. Getting it? What will be ρ2? 0.9. What is 0.9? Specific gravity का definition क्या है? What is density of water? SI? 1000. This will be 0.9 into 1000. Answer will come negative. That means the air bubble is rising. Did you understand? Answer is minus of 0.0021 meter per second. Minus of 0.0021 meter per second. Minus means it is going up. Next question, right? A spherical ball of radius r a spherical ball of radius r and density rho. Spherical ball of radius r and density rho falls freely under gravity. Falls freely under gravity. Through a distance h before entering the tank of water. Before entering the tank of water. If after entering the water, the velocity of the ball does not change, find h. Chalo, do it. Okay, when a body falls from a height h, what is the velocity? Under root 2gh. And just after that it is entering liquid, and they are telling you the velocity is not changing. Means it has reached the terminal speed, no? Means what? Under root 2gh just before entering the water and the terminal speed just after entering the water is the same. So you can equate the answer with what? Under root 2gh. You can write under root 2gh is equal to Vt ka formula, na? Vt ka formula is what? 2 by 9 r square by eta g rho 1 minus rho 2. Okay. So you square both sides and get the value of h, na? We need only the answer in variables only. Next question. You just need to equate under root 2gh with Vt. So 2gh will become equal to Vt square, na? So h will become Vt square by 2g. And Vt square is that big formula. Next question. A small sphere falls from rest in a viscous liquid. Due to friction, heat is produced. Find the relation between the rate of production of heat, and the radius of the sphere at terminal speed ठीक है, क्या पूछे? रेट ऑफ मतलब अपॉन टाइम आएगा. Rate of production of heat is a form of energy, means it is energy upon time. What is energy upon time? Power. They are asking you power. समझ में आ रहा है? You can write over there rate of production of heat means power. You know all the formulas. What is power का formula? Instantaneous power का formula क्या है? FV, force into velocity, force into, ठीक है? देखिए इधर. अच्छा, कौन से वेलोसिटी पे पूछा है क्वेश्चन? टर्मिनल पे. तो वेलोसिटी विल बी टर्मिनल. F क्या रहेगा? F we have ना, स्टोक्स लॉ, 6 pi eta r vt. Power will become F into vt. So it will be 6 pi eta r vt square. एक मिनट. We just want to express a relation between radius and power. vt में कितना r होता है? 2 का square 4 and 1 5. So can I say it is proportional to r raised to 5? Understanding? vt के अंदर there is r square ना, का square will become 4, 1 will become 5.